Okay, so for this question, what am I seeing? I am seeing CNBC is reporting that the mean cost of auto insurance is $1,018. Is that what you folks are paying? You're probably paying more than that, aren't you? Of course, this is the mean, and they aren't telling us an age, so you guys have a little bit different group. So what that tells me is, and it tells me it's normally distributed, so that's important. So that means I can do a normal curve. And then they're telling me that the mean is 1018, and then the standard deviation. So the standard deviation is 242. Now, this is, see how this capital is? So this is a little bit of notation that I want you to see. This capital X means for a single individual. So there, this isn't a sample. So this isn't the central limit theorem. So what this tells me is this is normal. So I have a normal distribution. Of course, he told me it was normal. And it has a mean of 1018 and a standard deviation, we'll use that fancy symbol for standard deviation of 242. And that works for any individual. So if I wanted to compare my insurance to this distribution, I could just say, let's see, what is my car insurance? It's about, I think I'm paying a little over $200 every 6 months. So what I could do is I could do that 68, 95, 99.7 rule, right? I really don't want to do all that, but I could. And then I could figure out where my $400 falls, and then I could use that David Lane applet to figure out what percent of people do pay more than me or less than me. But that isn't what this is asking. This is just asking me, what's the distribution look like? Well, I see that N there, see that N? That means normal. So yes, it is normal. And so that was easy, kind of a no-brainer. And because we know the mean for everybody is 1018, that's the mean for this distribution, and we know the standard deviation is 242. All right, so just since I've got the tools here, see how I'm right? See how I've got those right? Isn't that a wonderful thing? Now we come down to the X bar. So now we're talking about that, that guy that we saw yesterday. It's a pile of X bars. So now we're no longer for a single people, we're in for a sampling distribution. And they're telling us there's a random sample of 15 cars or 15 automobile policies. So what we have to do for this one now, the central limit theorem kicks in, and because we got a normal parent distribution, we're going to divide that by the square root of the sample size, and we've got 15. So I'm going to grab my calculator, and I'm going to do this off screen. Let's see, where's my calculator? Here it is. So I'm going to do 242 divided by the square root of 15. So 242 divided by the square root of 15. And that's telling me it's just only a standard deviation of 62 point, how many decimal places do they want? 4 decimal places. So I've got to do, that works out to be 62.484. Well, my calculator says, I better do the rounding for you. 13, and I want to round to 4 decimal places. So since the 3 is less than 5, I'm going to leave it as 62.4841. So the mean of this pile of p hats or pile of X bars is the same. It's normal. Central limit theorem tells us the sampling distribution is normal. That's the beautiful thing about it. And then it only has a standard deviation of 62.4841. Let's see, I'm going to cheat and make sure I agree. So it agrees with me, okay? So that's less variation in a sampling distribution than there is for than it is for the population. Now for part C, what's the probability that one randomly sampled automobile insurance is more than $1,012? Well, see how it's one car? So we want this distribution. We don't want the sampling distribution. So I'm going to pull up David Lane, and I'm going to type in, I want an area from a value. I'm looking for a probability. So because I want that, I want that first distribution, not the sampling distribution. I'm going to type in 1018. The standard deviation for any single policy is 242. And we want to know more than, so above 1012. And I'm going to click calculate, and it shows me that it's just a little bit less than the mean. And so we would expect to be just a little bit more than 50%. So that's what goes there. Now for the part two, we get a random sample of 15 automobile policies. So now we're into a sampling distribution, right? Because they're talking, how does the average of those 15 automobile policies compare to all the averages? So there we're in the second distribution, same mean, but we have a smaller standard deviation. So I'm going to type in that 4841 and calculate that. And it's a little bit bigger, less variation. The standard deviation was smaller. We'd expect less variation. So let's submit and see how I did. And I got them all right. Okay, so got to pay attention. Is it a sampling distribution? Do you have a sample? Well, if it's a sample, then you got to take care of that. You've got to take care of that standard deviation with that central limit formula. So, and what we do, when you saw this on the videos, it's the standard deviation for all that pile of X bars. You take the population standard deviation, divide it by the square root of the sample size. So that's what you got to do when you have a sample going on. Okay. This doesn't seem like much, folks, but this is a powerful thing where we're going to go next with this. It's fantastic. I mean, it's magic where we go next with this. So that's that problem. Let me stop this. I'll get it uploaded and you can try this yourself.